I'll be bringing with me a 3D printer in order to show you the entire process, how to move. Maybe sometime people will not be able to join. So I'll start directly my presentation by sharing my screen. What we are going to do today is a challenging topic, let's say, which is just if you can confirm me that you can see my screen, please. Just okay, great, great. Before even I start, I'd like to tell you that you have great interest to follow our social media accounts. It's I will type it in the 01.education on Instagram and on Facebook. This is the account 01.education. Okay, very soon we will start posting and hosting like small experience and small experimentation and small projects in robotics, in Arduino, even in coding, Scratch or Python or even 3D design. That's why you have a great interest to follow our social media, to stay aware of the projects, and you might ask us to send you the video even in order to share them at your class. Today, the main issue of this experimentation is to show you. Can you please off your cameras? All right, thank you. So, is to show you how we can move from the idea to a simulation project, then to a hardware final project, and why not even combining them with a 3D design concept. So, as I mentioned before, what I'm going to explain, and you are going to see how it will be easy for you to implement this technology, even if you don't have the background in Arduino and in electronics. This webinar is made for the beginners and even for the one who has experience in Tinkercad, because we are going to show in Arduino, sorry, because we are going to show a process of tasks, all right? And this process was tested before with teachers, with students, and it shows a high rate of functionality and result. So what we are going to start with is to create a rotating solar panel, okay, to make a solar panel follow the light from left to right. So for those who don't have previous experience in Arduino, I'll start by showing you that this is a servo motor. It can rotate 180 degrees, 90 degrees to the left and 90 degrees to the right. And it has three cables. We are going to show you later on Tinkercad in detail. You have yellow, red, and brown. It's always like that. Okay, so this is the servo motor. Then I have what we call the LDR. Also, we are going to see on Tinkercad. And this, so by the way, the servo motor is considered as an output device. All right. And then we have the LDR, which is considered as a input device, and this LDR, it has the capacity to read the quantity of light from the surrounding. So we are going to work with an input device and an output device, and the Arduino is going to control both. I will start by the simulation, and this is how you are going to deal with your students. please do remember always that what we are going to do right now, it's not the beginning of the path. I mean, if you are teaching Arduino or you are not teaching Arduino and you want to start this process or the microcontroller process, it's not the right project to start with. It will be like an end project later on. What you are asked to do to start with Arduino is like simple LED blinking, push button, servo motor alone, ultrasonic alone. So what we are going to do now is like a complete project, and this is very important because I believe that when I show you the output of this complete project, okay, you are going to be more interested and excited in order to start this process at school. Even if you are using our curriculum 01, the ICT and robotics curriculum 01, because I know that many of you are started using our curriculum where all those skills are included. And for the schools who aren't using yet our curriculum, I invite you to explore the content. You can send me later on a message on my WhatsApp to send you all the details regarding this content in terms of scope and sequence and other. So first of all, I said that we are going to start with what we call a simulator process. So I believe you all have an account on Tinkercad. So if you don't have the account on Tinkercad, please do create one later on, because it's really important to have it in terms of circuits for Arduino and microbit, and even for the 3D design that you are going to use. So directly from my account, I'm already logged to my account. I click on my icon on the top right, new design, and then I choose circuit. And as you will see, there is a page, a blank page opened. Directly, I'll be moving an Arduino board and a breadboard. Uh, uh, can you write on the chat if you want me to explain a little bit the characteristics of the pins, or you already know them? Please send me on the chat if yes, you need some details, or you already know. No. Okay, great. So for the Arduino board, quickly, you can see that you have two rows of pins. You have on top and you have on bottom, exactly like the Arduino that I'm holding here. So what you can see as similar pins, that you have just let me open the pen, the pen, excuse me. So you can see that you have here pins from 0 to 13, which are digital pins that we can control from the program of Arduino. I have here a ground pin, and then down for the power, I have two ground pins. They are similar. I have one 5-volt pin, and then I have analog pin. So for students, you have to concentrate on those pins. I mean, the digital pins, and you are going to explore them, the analog pin, and two types of pins, which are the ground and the 5-volt. For the rest, the AREF, forget about. All those, forget about. And here the VIN also you don't need. So it's limited to digital pin, analog pin, the 5-volt, and the ground. Okay, this is first. what I have here is the breadboard. And this breadboard is like the socket wire where I can plug many sockets. So here I'm plugging cables. So imagine if I want to make one LED blink. This is not our context, but I will show you. So no need for the breadboard. I can delete it. Sorry. I can delete my breadboard. No need. I can move my LED like this. I can connect with a cable. I can connect my LED the anode to digital pin 12 and the cathode for on the ground. Okay. Then I go to the code. And as you can see, it's a scratch program. I set my digital pin 12 to high. I wait for 1 second and I duplicate and then I put it to low. And when I click on start simulation, you will be seeing that the LED start blinking. This is good for one input or one output device. So I do not need like a breadboard. But when it comes to a bigger project, so I need a breadboard, and this breadboard, it's very simple as constitution. It's formed of like 4 sections. I have the upper section, I have the lower section, I have inside one section and the other section. So you have 4 sections. The characteristics of those sections is that the pins where I plug my cables, my wires, are connected even horizontally, even vertically. For the upper section, like here and like here, lower section, pins are connected or the holes are connected horizontally. And for the intersection, as you can see here and here, so pins or holes are connected vertically. What I'm going to show you right now is that I'm going to program alone the LDR. Then I will show you how to program alone the servo motor, okay? And then how to combine both together. And this is how you should proceed in the classroom. It is impossible to make the entire process in one session as a final project. So you will start simply by controlling the LDR to see the quantity of lights you are reading from. So I will select from my right column the LDR, which is the photoresistor. Look here, the 2 legs don't have any characteristics. So it's like terminal 1 and terminal 2. I will insert the photoresistor on my breadboard, as you can see here. Look here, I did the project, so it's inserted. I don't know if it's clear, but let me just. So the LDR is here. This is the LDR. So I insert it on my breadboard, as you can see. Okay. Excuse me. And how to build the LDR? It's like common, and it's always like that. From to control the LDR and to make it working correctly, I have to add a resistor. Maybe later on we'll talk about the resistor, but because it will take too much time for that. But do understand that this resistor is to minimize the flow of the current, and this concept is used in physics, in electricity, for students in higher grades like in 10, 11, and 12. So I will rotate it horizontally, okay, and I will plug it on the same column as you can see here, on the same column for one terminal. Then I will take a 5-volt directly cable to the terminal number 2, and from the other side I will take a cable to the ground. Why I'm doing this? Because it's like a simple project for one element, which is the LDR. Now, later, when I will be combining LDR with a servo motor, the circuit will change a bit. And to complete my circuit, I will connect a cable from this hole to the analog pin 0. I can connect it to analog pin 0, to analog pin 1, 2, 3, to 5. All are the same. So this kind of circuit, it's a common circuit that will never change. Always, you as teachers and even your students should memorize or understand the circuit always to be done like this. Okay? I repeat, one leg is connected to the 5 ground. For the other leg, from one side, I will connect it to the A0, and then you will place a resistor, but here you should put it as the value 10 kilo ohm. And by the way, in order to work with Arduino in the classroom or even at home if you want, you should have this multimeter in order to test the value of the resistors, because once it's a new resistor, like this one, you can see that it's written for example here, it's like 10K. This resistor is 10K. But the moment you remove the resistor from the paper, from the as a new, and you will be using it, then after you have to measure this resistor. So you are obliged to use a multimeter. And then after, from the other side, I'll be connecting one wire to the A0. And what is an analog pin? The analog pin, simply, it's a pin that can read values from different levels. I mean, for the light, it's not about the light cannot take the values 1 or 0. If it's too much sun, it's the value can take the value of 900, and if it's too dark, it will take like 0, 1, 2, 3, 4, 5, and in between it will take different values. So the analog pin will give the Arduino board the reading of the LDR for different values in order to process it. Okay, so as a first project, I repeat, we have to divide our projects into different modules. All right, so I'm doing here my LDR. It's simple. Then I'll be showing you how to do the servo alone, and this is what you are asked to make on with your students, and I will be showing you at the end a combination of LDR and servo motor. This is the best way from what I've experienced with students and teachers that you have to explore. Do the first part LDR. If it's working, great. Move to in a second session, move to the servo motor alone. If it's working, great. And then combine both together in order to see the entire project where the servo motor is following the sun left and right. So now it's time to the coding process. All right. So what I'll be doing, I'll be clicking on code. Okay. And since the LDR, as I told you, it's an input device. So I will be clicking on the input and moving the block read analog pin. Okay. And it's connected to A0. If it was connected to A1, I have to change here the value. And from the output, I click on print to serial monitor, and I place inside the read analog pin. So believe me, your students will not find there is no offline version of Tinkercad, unfortunately. Okay. So what you are going to explore here is printing the value of the reading of the LDR or the photoresistor. So I'm asking here from my computer to print on my serial monitor what he is reading on the LDR, and to slow it down, I will be adding a 1 second delay. So if I click on start simulation, just 1 second. Okay, look down the serial monitor icon. I will open it, and then you can see that there is values 54. How to check if my circuit is correct? I click on the photoresistor and I move the slider, and you can see that the slider is working and the value now is 974, 951, 850, 700, and then 54. So my circuit is correct. If you want to add like an animation or let's say to add a LED in order to make a LED on and off with the LDR. So look how easy it is. So I will move a LED. I will place it here. From the leg, from the anode, I will connect it to, let's say, the digital pin 6, and the other one, I will connect it to the ground. Okay, and that's it. Then I go to code, and I will be creating a, let's say, a if condition saying that from the math block, if my LDR is less than 500, the output set pin A6 to high or set pin 6 to low. Look how easy the programming process is done. Okay, please just write me on the chat if till now the process is clear and you feel like you are ready to do this. But I will click on start simulation, And look, now the LED is on because the is less than 500, and if there is sun, so the LED will turn off and the LED will turn on. It's clear. All right. Thank you very much. All right. It's all clear. Thank you. Okay, great. Amazing. All right. So this is how I can build my circuit for the LDR. If you want to play with your students with projects, you can add one LED, two LEDs to make this condition. Now this is simulation. But how to move to what we call the hardware? So as I showed you here, I already built my circuit, okay, but I did not place a LED. I completed with the motor, so all is complete here. But to show you how I can move from virtual to simulation, it's an easy process, believe me. All I have to click to do is to stop the simulation, to click on code, okay? And from this section, which is the block code, click on the drop-down menu and select block and text. Look how amazing the process is. So the C++ code is already generated. So I select my code, I copy it. It's very simple. It's very simple. I go to my Arduino software. This is Arduino software. I will delete all. I will delete all the code, and then I will paste the code. And here you have to know, if you are new with Arduino, that students are not obliged to memorize the C++ code like Python. Here, students should know how to modify the code, and do not do this mistake. It's very simple. Since Tinkercad is transforming the code from blocks to C++, so no need to make this task hard for students. Okay, that's why what I ask you to do is to explain a little bit the sections of the program, what does the serial monitor do, and the condition, how it's written, but not to memorize the entire code. So once my code is here, I make sure that on tools port that my Arduino board is connected to my device. Since now my Arduino that I showed you on the table is connected to my computer, so I'll be uploading the file. Look here, uploading is done, and I'll open my serial monitor. And this is very critical because on the Arduino board, you don't have a screen to see the value read by the photoresistor. So you have to find somehow how to read the values to check if it's okay or not. So as simple, you click on the serial monitor and you can see that the values here are like 900, 700. I will hide the LDR, and you can see that the value is 350, 320, 324, 28. I will hide more, and you will see that the value is, I have to hide more. Okay, look here, it's like 300. I remove my hand, it's again 900. All right? So when I put my hand, it's like down. When I remove my hand, it's like sun. So it's night and day. So my circuit is working, and this is how I'm going to show here, for example. So now I put my hands. Look here, the values are like 400. I remove my hand, it's like 900. I put my hand, it's like 300. I remove my hand, it's like 900. So my circuit is 100% working. And then do believe that you cannot find, here I have in this bag, like 20 LDRs. Okay? Always believe that each LDR has a special reading. You cannot find two LDRs that can read same values 100%. It's not really accurate, but after all, we are talking about education. Okay? So I will close my serial monitor. I'll go back to the to Tinkercad. All right. I will open Jeddah demo 1. Okay. I will open, I will go back to my, okay. I will duplicate the circuit. Okay. I will delete my LDR to make it a bit quick. And this to make it simple. I move my servo motor. And as I told you before, that my servo motor has 3 pins. When you place the mouse on one of the holes, it shows you that this is the ground, which is the brown. This is the power, which is the red. And this is the signal, which is the digital pin. So I delete all. Okay. And then I can directly, and here, no need for a breadboard. The ground, I can connect it to the ground. The 5-volt, I can connect it to the power. And then the digital signal, I can connect it to the digital pin, let's say 6. And even I can delete my breadboard. And then here, how to program this, this device. It's very simple. I open the code, okay, and I delete all. And since my motor, it's an output device, so I have to go to the output device and look here, rotate servo motor on pin 6 to 0 degrees. I add the weight pin and I duplicate and I choose a 90 degrees. Since I told you that this servo motor can turn like for 180 degrees, 90 degrees to the left and 90 degrees to the right. And this is a perfect output device in order to create a mechanical movement with precision, since we can control the rotation by degree. So there is inside a gears. No, I did not get the on off. What do you mean by on off? Sorry. So what you have here is a servo motor that you can control even by 1 degree. And this is ideal for like a barrier gate, like a sliding door, like rolling shutters, like rotating motor to precise the degrees. So when I click on the start simulation, look here how the motor will be turning for 90 degrees. If you want to make it like to 180 degrees, so I can change the value, start simulation, and it's turning for like 180 degrees. Okay, yes. We will be combining them together now. Yes, exactly. Thank you. All right. So till now, what we saw how to. Okay, I will copy the code. Sorry. I will open the code. I will click here on the block and text. I will copy the code. Then I will move to. I'll move to Arduino. I will select the old code. I will paste my code. Then I will upload the code. There is just 1 second because sometimes. So here now I'm facing some issues of uh, rotating because the power that the Arduino board is giving is not enough. So you can see that, sorry, I cannot see myself. I have to open the camera. Just 1 second, please. So so you can see that my servo motor now, it's producing a sound, but actually it's not. I don't know if you can see. I have an issue in my breadboard. Okay, good. Excuse me, just because I'm trying to fix the issue. Sometimes there is an issue of cables. Sometimes there is an issue of. Because the breadboard I'm using, it's a used one, so sometimes the holes are not really tight. Okay. Actually, it should work, but I don't know why. The minus here, the ground. I'll try to take directly from. Okay, you can see now that it's working. So it's an issue of the breadboard. Okay. So you can see that it's working 100%. So okay. Back to my presentation, and I have to move to my last section, which is code, which is combining. Uh, I cannot explain without seeing myself. So, okay, there is a question on the chat. Okay, great, amazing. Thank you. So the third part will be to combine a photoresistor with a servo motor in order to control the action of the servo motor with the photoresistor. So I will try to make a project from scratch. Like this, it will be like a revision. And since our session is recorded, so you can go back to it later on. So I will take my breadboard. I will place my photoresistor. I will move a resistor. I will make it horizontal and set its value to 10K. I will place it on the first leg to the left. Now, since I will also add a servo motor. Maybe I can make, I can choose the mini. Okay, no problem. All right. Okay. So since now I have two elements that I'm adding, I have interest, and please here listen well to this remark. I have interest to keep, to use the row of the breadboard for the ground and for the 5 volt, since I'll be using them for the photoresistor and the servo motor. So look what I'll be doing. I will take I'll take a cable from the 5 volt, and instead of putting it directly to the photoresistor, I will plug it here. Okay, so the 5 volt is the plus in electricity. And from this line, since all the dots now are connected, I can take a cable from the first row to here, and from this up to the power which is in the middle. I finish with the ground. Look how logical is the steps. And then after, from the ground, I will take and connect to this row, okay? And from this pin, I will connect to the brown, which is the ground for the servo motor. And then from the ground, I will connect to the other edge of the resistor. It's done. It's done already. The ground and the 5 volt are connected both to the photoresistor and for the servo motor. I all need now is to connect my A0 to this dot. So I will make it up. It's better maybe. And I can change even the color for data like yellow, let's say. And from the digital pin 6, I can connect to the signal. And here all right. And my circuit is already done. So I'm adding LDR or photoresistor and the servo motor. This is the complete circuit for the third session that you should be doing with your students. As I said before, the first one is the photoresistor. The second one is for the servo motor, and now we are combining both together. So I'll go to the code. I will choose only the block code, and then I will start controlling the LDR. So as a first step, from the output, print to serial monitor the read analog pin A0. This is a must to always see what's happening. Okay, I can delete, I can keep this because I will be using them. And then from the control, I can select my else if, and create a comparison block by saying that if the read analog pin is less than 300, let's say, all right, turn my servo motor to 0. Please write me in the chat if the code is clear. And I believe your students will really understand this since they are using Scratch. So is the code clear till now? Great. All right. So as simple, I will print on my serial monitor the value read by the photoresistor. Then if my analog pin A0 is less than 300, I will turn my servo motor to 0 degrees, and then else I will turn it to 180 degrees. All right? So I will click on Start Simulation. I have to move the, all right. And then, Start Simulation. I open my serial monitor. It's like 54. I click here. I slide down. Look how it turns to the left. Then it goes back to its initial position. I slide down. So it's greater than 300. It's less than 300. It's turning. Why the forever block is inside the start? Okay, the forever, why the forever block is not inside? Okay, look, because the on start will be Mrs. Hosniya is asking why the forever block is not inside the start block, because there is a big difference. The on start, it's like when you will be running the project, the blocks inside the on start, it will be run one time. But the forever loop, it will turn always and always. Okay? So I believe it should be clear. I close the chat. So now I'll be taking my code, stop simulation. I'll try to take my code as a block and text. Look here, you have two procedure. The first one is called setup. The second one is called loop. And if I copy the code and then go back to the Arduino, all right, I select all my code, I paste, then I upload. Hopefully it will work. All right. So let's see what's happening. Why it's turning like this. It's always turning. You can see maybe to check the values, I have to click on the serial monitor. Look, the values are really critical here. The moment the value of the light is less than 300, it's turning. But when I hide my, I will open my flashlight. Something wrong. Okay, just 1 second. There is something wrong. Let's just one moment to fix. It's like A0, A6. you see that always there is some challenges. Uh, it's not reading well now. Let me check with the. So now I have some issue of the circuit. It's not reading 100%. Let me check. Uh, Let me check with the code. I'm attaching my servo motor on 6. It's okay. The A0. So I believe here it's an issue of cabling now. I will open again the serial monitor. It's reading. You see, when it's reading 0, it means like there is an issue of reading values. So maybe sometimes the cable are not plugged well. Uh-huh. You see, when I'm moving a little bit my circuit. I'm trying to change a little bit the place of the holes. You see now? So the moment it's less than 300, it's working. And when it's come to greater than 300, it's working to the left side. But the moment, so here it's not turning because it's always greater than 300. And the moment it's less than 200, it's turning. So I believe it shows you that it's working. Now to go back to enough turning. Okay, I will open off my. So now back to my initial idea of project. I said I want to create a rotating solar panel to turn left and right. Okay, like if the solar panel will turn following the sun. So my left hand will be the sun. So when the sun is moving from one side to another, so the solar panel should turn from left to right, or maybe from the yes, it's maybe the resistor value is high. No, it's always okay, but I'm using an old breadboard. Maybe the cables even they are used by students, so you might have this issue. And this is a part from the game. So when you are dealing with Arduino, you should know that the hardware part is a part of the game. In order to debug and to fix the issues, sometimes you have a problem of power. That's why, look here, I've added here a 9 battery volt, okay, to my circuit in order to give enough power for my project. So if I go back to yes, it's an idea of the sunflower project, 100%. Okay, so if I go back to my project, and to make the servo motor turn to the right and to the left, so it's very simple. I have to duplicate the LDR, to place another another resistor to move the the 5 volt to this leg. I will make it green. And from the ground to this part, and I will place my second part of the terminal to, let's say, pin A A4. So I have now two LDRs. I should place them at the extreme of my breadboard. It's okay, fine. So I have two LDRs. One is like connected to A0 and the second one is to A4. So as simple, to create this project, all I need to do is to go to the code, and instead of look how easy it will be right now, instead of creating this condition less than 200, I will go to the input and then place here A4. And this is it. I did not make any modification else than changing the condition. So where the sun is bigger, my solar panel will rotate to this side or to the other side. So if I click on start simulation, okay, look here. When I click, it's not working. Why it's not working? A0 and A4. Start simulation. All right. Okay. Look here. So you see that. So it's kind of testing on the ground the value of the sun by placing two LDRs, one to the left and one to the right, and it's a matter of reading values by placing your cellular phone to the right and to the left, and it should be like this. So I believe that I gave you a clear idea about how things should be moving from left to right, okay? And what you are asked to do now is to create like a trial project at Tinkercad. And when I'll be visiting Jeddah, inshallah, we will be having hands-on project. And if you have the kit, you can try it on your kit. In case you have any problem, you can contact me. But always be aware that sometimes the hardware of Arduino might produce some error of connecting. So it's about experience in order to do this. Okay, I will be showing you just 1 second. All right. So to end this presentation, I told you that we can link, or we have to link our Arduino project with a 3D design option. And as you can, you know that on Tinkercad, you can go to on the section where you can create a 3D design. Okay, and why it's very important Sorry. I'm not sharing my screen. Excuse me. Sorry. So now you can see my screen, I believe. No? You can see my 3D design screen. Okay, great. All right. So now uh, on the 3D section of Tinkercad, you can ask your students to innovate any kind of construction or 3D modeling system in order to have like a holder for the servo motor, like I did here. So what you can see here, it's a product made on 3D design where I can plug my where I can plug my servo motor. Look how accurate it is. Okay, so look now, my servo motor is in a holder, and for the I did another project which is the where are participants? Okay, no, my God. Just a second. I shared my screen again. I share my screen. So you can see that. All right. And here with my ultrasonic sensor, I've created another 3D model where I can plug my Arduino in this way. And from down, I have created a small hole. I don't know if you can see it. So as a project or as an idea for project later on, what you can do is you can fix your ultrasonic sensor to the servo motor, and you can create a project where the servo motor will make the ultrasonic sensor turn left and right in order to monitor if there is any person in a room or there is any movement. You can reproduce a sound or you can add a counter for this. So as an advice for you, the 3D design process, it's something which is very important in order to extend your experience in teaching STEAM education and link it to the 3D design with Arduino modeling, as I showed you now. And even for the robotics, there is also a great opportunity for modeling extra kits in order to add it to the robot you have, especially if you have the MBOT2 robot where the structure is in metal and it's all around with holes in order to create additional features for that. You might tell me that we don't have a 3D printer at school. It's okay, but the idea here is like you have to open this window for your students, and for all the schools who are working with us during my visit, we will be providing them many 3D design made for the MBOT robot and for Arduinos in order to use them in their computer lab. And hopefully they will get soon this 3D printer so they can enjoy printing any design they will share with the students. So basically, this is what I was intended to explain. If you have any question, please feel free to ask. Just okay. I'm just attendance. I'm creating the Google form. March 2024. Just to send you the certificate of participation, I'm creating a Google form in order to send it to you by chat. It will take me like less than 1 minute. Please stay tuned. And each person that will be sending me okay, just 1 second. Delete this. Okay. So please write your name and your first name, like if it should be shown on the copy. Okay, it's done almost. So I'll be sending you on the chat now the Google form in order to fill your information in order to receive the certificate of the participation. Okay, so sure, I'll be sending you the recorded session. And as I said before, you have a high interest in following us on our social media in order to stay informed about any educational resources that we will be posting. So it's 01.education on Instagram and on Facebook. So I advise you to follow our social media for that. A reminder for teachers here that are not using our curriculum 01, I really advise them to contact me by WhatsApp in order to send you the entire brochure and to discuss it with your academic directors, because all what I have talked about today, it's in the curriculum. So you have great interest to move from what you have if you believe that really what we